So switching gears and starting to talk about naming compounds here. Well, first of all, we've got this nice little alcohol. So we first of all find the longest chain. There it is, 1, 2, 3, 4, 5. So that makes it pent. We then have to number these atoms, and we do it so that the OH as the dominant group over a methyl group is the lower number. So that means this is carbon 1. And after carbon 1 comes carbon 2. So this 1 here means it's an an-1-ol, and the 2 there means it's 2-methyl. So put it all together, 2-methyl pentan 1-ol. Systematic name of this compound here. Now I say below because I've expanded it out. So CH3, CH2C with the chloride, double bond CH2. So longest chain that includes the double bond 1, 2, 3, 4 means it's a bute. Double bond will determine where the numbering starts, so 1, 2, and of course the chloro therefore is 2. So the whole thing becomes 2-chloro-bute-1-ene. Look at those pretty colours. Skeletal structure of 2-bromo-3-methyl-butane. Well, first of all, we want butane, 1, 2, 3, 4. Number it 1, 2, 3. We want to put a bromine at carbon 2 and a methyl at carbon 3, and there's the skeletal structure for it. Displayed formula of pent-2-ine. Now this goes back to the older specs, 2015, where ines you talk about being triple bonds. Okay, not too tough though, exactly the same idea. Pent, 1, 2, 3, 4, 5. Number it, carbon 2, so therefore because it's 2-ine, the triple bond starts at carbon 2. And now let's fill out all those hydrogens. 2,3-dichloropropene with pretty colors already. The prop, 3 carbons in a row. The ene starts there. That defines carbon 1, and you don't need to say it's prop 1-ene because it could only start at carbon 1. And then we've got some numbering to do, 1, 2, 3, because we've got chlorines to put on carbon 2 and 3, and then throw in all those extra little hydrogens. Skeletal structure of 3-chloro-2,2-dimethylpentane. Well, first of all, there's a pentane, 1, 2, and 3. We've got to put 2 methyl groups on carbon 2 and a chlorine on carbon 3. There's the 2 methyl groups, there's the chlorine. Had students ask, does it matter where you put those two? Some would like to have one going straight up, one going straight down. That's okay. I mean, it's showing the same thing, but it's not nearly as pretty as having it arranged like this. Displayed formula of E-pent-2-ene. So this is where we're bringing in this isomer idea that we'll delve into in greater depth in future questions. So we got pent, 1, 2, 3, 4, 5, 2. So the double bond starts at carbon 2 there. Now to get the E, we have to put the higher priority group on each of these carbons on opposite sides. Now if we look at carbon 2, it's got a CH3 and then a hydrogen we haven't drawn. If we look at carbon 3, it's got a C2CH3 there and a hydrogen that I haven't drawn. Higher priority on both is the non-hydrogen bit, so the methyl and the ethyl. And we have to put those on opposite sides. So there we are, there's the double bond, there's the methyl and the H, there's the H and the ethyl, and notice the methyl and the ethyl on opposite sides. And now we just need to fill in with all the pretty hydrogens. Skeletal formula, 3-chlorohex-1-ene. There's hex, 1, 2, 3, 4, 5, 6. Carbon 1 is where the double bond starts, so there we are, and then 3-chloro, we got to put a chlorine there on carbon 3, right there. Why did I not worry about E and Z? Well, we might as well anticipate future questions, because to distinguish between E and Z, or for E and Z isomers to exist, you have to have different things on each of the 2 double bond carbons. This carbon here, carbon 2, has got a hydrogen and then the big rest of the molecule, but carbon 1 has 2 hydrogens, thus no EZ possibilities. Continuing on, name the compound, whose formula is shown below. Well, we've got an acid group there, so we need to have the longest chain that contains that acid. So we've got 1, 2, 3, 4, 5, so that tells us it's pent. and anoic acid. And then what else do we have floating around here? Well, we've got methyl chloride and methyl. We need to be able to say where they are. The acid group determines unambiguously that's carbon 1. So we got 2 methyl, 3 chloro, 4 methyl. And putting all those together then, chloro comes before methyl, so 3 chloro, we got 2 methyl, so it's dimethyl, the carbons 2 and 4, and then of course the pentanoic acid. Skeletal formula. Started off with the pentane, there's the COOH there, putting in the chloro, and then putting in the methyls. Name and structural formula of a tertiary alcohol that contains 5 carbon atoms. Well, a tertiary alcohol's got a carbon bonded to the OH and then 3 more carbons on it. So that's already 1, 2, 3, 4 carbon atoms. So the 5th carbon atom just has to go on any of these ones. It could go there, could go there, could go there. Makes no difference at all. Now let's name that. Well, the longest chain is carbon, 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 carbon. So it's a bute. Then the numbering scheme so that this is the lowest possible, so 1, 2, and both the OH and this methyl group are on the 2nd carbon, carbon 2, so it becomes 2-methyl butane 2-ol. So draw the structure of secondary alcohol, contains 6 carbon atoms, and name it. So I'm going to go a bit overboard here because I love isomer questions. And if we've got an alcohol that contains 6 carbon atoms, the alcohol you just plug in to the carbon framework. So therefore we can start off by saying, let's consider the different isomers of 6 carbon atoms. In other words, the different isomers of hexane. And then we're just going to add an OH on a secondary carbon to do it. So we got hexane, we got 2-methyl pentane, 3-methyl pentane. I could go ahead and do the other one, but I'll come to that in a minute. So anyway, so let's find our secondary carbons. So in hexane, there's a secondary carbon at carbon 2 and one at carbon 3. Remember, carbon 4 is the same as carbon 3, carbon 5 is the same as carbon 2. So let's pop in those OHs. There's one on the secondary carbon at carbon 2, one on the secondary carbon at carbon 3. This would be hexane 2-ol and hexane 3-ol, or 2-hexanol, 3-hexanol, if you're an old person like I am. Now let's look at the 2-methyl pentane. We've got a secondary carbon there at carbon 3 and a secondary carbon there at carbon 4. Okay, although of course we've got a little trick coming when we think about that as carbon 4. So first of all, let's put the OH there at carbon 3. So this will be 2-methyl pentane 3-ol. Now we put it there at what I said was carbon 4, except of course that the OH is higher priority than the methyl group for determining the numbering scheme. So this is carbon 2, that's carbon 4, so it becomes 4-methyl pentane 2-ol. Let's go to our 3-methyl pentane, and only there is a secondary carbon. This of course is the same as that one. So putting it there, and it will be 3-methyl pentane 2-ol. So there we have 5 secondary alcohols that contain 6 carbon atoms.